So this is looking at index rules, the basics, and you may have already seen the videos on multiplying and dividing with indices. Well, this recaps that and just moves it on slightly. So let's just look at multiplying when we have indices, and what you should remember is when the bases are the same, these are the bases are the same, and they're multiplying, we can add the indices. So this would become 5 because the base is 5, and we add the indices and it's 7. Okay, so 2 to the power 8 multiply 2 to the power 4. The base is the same. You must make sure the base is the same because this rule does not work if those bases are not the same. So that would be 2, and it's multiplying, so I add my indices. And here, is the base the same? Yes, the base is the same. I'm multiplying, so I can add my indices. So that's from my previous videos. Now, recapping dividing. 5 to the power 4 divided by 5 to the power 3 again. Bases have to be the same. Bases stay the same. And because we're dividing, we subtract. So it's 1, 5 to the power 1, which we just would write as 5. We wouldn't leave the 1 there. So it's okay to have that 1 as your workings, but we wouldn't leave it there for the final answer. So what about this one? What do you think you'd write for this one? What would your base be? 2, I hope you're saying in your head. And what would the power be? Remember, we're dividing. So that would be 4. Here, let's start. What's the base going to be? It'd be y. And what would the power now be? So remember, we're dividing. So we subtract. So that would be 3. So key thing here, check the base is always the same. Doesn't work if they're not. The base always remains the same. And then if they're multiplying, you add. If you're dividing, you subtract the indices. Okay, it's just the indices you subtract for dividing. It's just the indices you add to get the new index when you're multiplying. That should be a recap. You should be quite confident there. Other things to recap, anything to power 0 is 1. So 4 to the power 0, that's 1. 7 to the power 0, that's 1. Y to the power 0, that is 1. What about to the power 1? Well, 4 to the power 1 is 4. We dealt with this on the previous slide here, if you remember. This one here, because anything to the power 1 is just that value. 7 to the power 1, that's 7. Y to the power 1, that would just be y. So that knowledge should already be there with us. We should already be quite confident with those. And here's the new bit. So here we've got 3 squared to the power of 4. Now 3 squared to the power of 4, what this means is 3 squared multiplied by 3 squared multiplied by 3 squared multiplied by 3 squared. Because when you raise something to the power of 4, you're saying multiply it by itself 4 times. So it's 3 squared multiplied by 3 squared multiplied by 3 squared multiplied by 3 squared. I can now go back and use my rule because my bases are the same. So I know this will be my new base. It will be the same. And I've got a squared, these are multiplying. So if my bases are the same and I am multiplying, I would add 2 plus 2 plus 2 plus 2, which is 8. Now what I want you to do is that is 8. Can you see any relationship between these two on how I could get 8? Can you think of a way using 2 and 4 I could get 8? Okay, keep keep that thought, say it out loud. How do you think you would get 8 from 2 and 4? And now we're going to do this one. So this is 2 cubed cubes. So 2 cubed is that. But if I cube it, I mean I multiply it by itself 3 times. So using the multiplicative rule for indices, are the bases the same? Yes, they are. They're all 2, so I'm going to write 2 as my base. And what do I do with the indices when they're multiplying? I add them, so 3, add another 3, add another 3, that's 9. Oh, I've got 9 now. How does that link to these two numbers? Now, what I hope you've noticed is that 2 multiplied by 4 is 8, and 3 multiplied by 3 is 9. So this new rule is that when the indices are like this, so this is called raising one power to another power, so it's 1 to another power, we actually multiply. So you can see we've multiplied to get this 8 and multiplied to get this 9. So when they're just a whole line of multiplyings, we add. When it's dividing, we subtract. And when we have a power raised to another power, we multiply. So let's look at these. How would I do this? Well, this would be 4. And this index would be 2 multiplied by 7. So that would be 4 to the 14. Here, 2 to the and 5 multiplied by 2. So that would be 2 to the 10. And here x, and it's 2 multiplied by 4. So it would be x to the 8. So moving on to, I want to just put all of those rules on one page. So here we go. And I do think this is something quite good to write down in your books because it's something you actually can come back to then when you're asked to do other questions. So when we're multiplying and the bases are the same, the base here is P, and we would do 7 add 3, so it would be P to the power of 10. Because when they're multiplying and the bases are the same, notice the language I'm using, I need you to be using that language, so they're multiplying with the bases the same, I add the index and I get 10. So here again, dividing, the bases are the same, so I put P, and they're dividing, so I now am going to subtract, and that's P to the power of 4. This one here is P, and here when it's a power to another power, we multiply. P to the 21. P to the 0, anything to the power of 0 is 1. And P to the 1 is P. So I am going to say it again because I need you not just to know this for this lesson, even for next lesson, I need you to know it for the whole of your time while you're doing maths, because this comes up in so many questions. It's really, really important. So here, when they're multiplying and the bases are the same, we add the indices. When we're dividing and the bases are the same, we subtract the indices. When it's one index raised to, or one power raised to another power, we multiply. Anything to the power of 0 is 1, and anything to the power of 1 is just itself. Make sure they're copied down.